In the previous session, we discussed about numerical examples in this topic of vector. And in this session also, we are going to continue with the numerical problems. So in the previous session, we discussed the numerical problems in the part of vector addition by triangular law and vector addition by just a graphical method. In this session, we are going to continue with the numerical problems in part of using the parallelogram law of vector addition. So I hope you remember about the parallelogram law, and we'll be using parallelogram law to solve for the resultant vector in this part. So in the first question, two forces of magnitude 40 Newton and 60 Newton are pulling a box in a horizontal table. If two forces make an angle of 60 between them, find the resultant force. So as usual, we are first making the scale. So I let 1 centimeter represent 1 centimeter represent, let's say, just 10 Newton. Therefore 40 Newton is represented by 4 centimeter, and 60 Newton is represented by 60 centimeter. So from there, angle between them, which is 60, tuanza na triangular law, then tafata parallelogram law. So by triangular law, 4 centimeter, I can simply draw even this way, 4 centimeter. From here up to here, it is 4 centimeter. Then from there, I measure my angle, which is 60, angle between them, which is 60. So I measure my angle. To drawing the first vector, I measure my angle. That is 60. Itakuwa ni hapo. So care must be taken. Kama unavyojua, errors ni nyingi, na ukosea kidogo tu umeshakosa swali. 6 cm. Kwa hiyo 6 cm hapo tupate nafika hapo, inafika mpaka hapo. Hiyo ndio 6 cm. Resultant ta measure, tapima toka pale, draw from here. So resultant will be 5.3 centimeter. 5.3 centimeter. So it is 5.3 centimeter, which when we are using our scale, itakuwa ni 53 Newton. Hilo ndio tutakuwa jibu letu by triangular law. Let's see by parallelogram law, ambayo nitachola my first side of parallelogram, which is 6 centimeter. So I start with that one, 6 centimeter. 6 centimeter. So unaweza kuona kwamba from here up to here, hii ni 6 centimeter mpaka kwenye dot hapo. So nita measure angle between them, which is 60. So I will be measuring angle between them. Nitapima hapo angle ya 60 ambayo ni hiyo hapo. Nikishapima angle ya 60, nitapima 4 centimeter 4 centimeter, about 4 centimeter itaanzia hapa up to here, that is 4 centimeter. So I will also measure an angle of 60 from here ili niweze kutengeneza parallelogram ambayo iko vizuri. So from here we measure an angle of 60 ambayo angle ya 60 itakuwa ni hii hapa. So nikisha measure angle ya 60 nitachora my dotted line here kuonyesha kwamba this is the image of the true vector. So dotted line up to here ambapo ni 4 centimeter. From there it is easy. I am simply connecting this point and this point with the dotted line. Unaweza kuona kabisa kwamba the vector hapo inakuwa ni 6 centimeter kama ya kule chini. So I am connecting the points with the dotted line. Then finally I draw the diagonal of my parallelogram. So I draw the diagonal. Now the diagonal is from here mpaka pale ambao unaweza kuona ni 8.7. Ni 8.7. Kwa hiyo ndio inakuwa resultant vector by parallelogram law 8.7. So tutasema 8.7 ambayo tukimultiply inakuwa ni 87 Newton. Tukimultiply by 10 inakuwa 87 Newton. So kifupi resultant vector kwa kutumia parallelogram na triangular law jibu linakuwa na tofautiana. So unaona hata hapo tukipima kwa triangular law ambayo tungepima hii hapa inakuwa ni 5.3 ile hii triangular, lakini parallelogram law jibu linatofautiana. Ndio maana swali liko nauliza find the resultant force on the box using triangular law na parallelogram law. So by triangular ni 53, by parallelogram ni 87. Swali la 5, suppose a man walking from point A, a distance of 20 meter due north and 15 meter due east, find his new position from A. Kwa ametembea from point A distance ya 20 meter due north and 15 meter due east. Kwa kuna kwenda north na kwenda east, then you find a new position from A. Hiyo ni resultant to vector hapo. So I hope you can even use Pythagoras theorem. Sometimes for questions like this unaweza kutumia tu hata direct Pythagoras theorem, due north and due east, presence of right angled triangle allow us to use the Pythagoras theorem na kuna yote atakaye to blame. You can also use triangular law, but triangular law is just 20 meter, 15 meter. Triangular law is the long method. However, you can use triangular law. So I will also try to solve this by using triangular law. And by using triangular law, tutaweka scale 1 centimeter represent 5 meter. So huyo hapo 20 atakuwa ni 4 centimeter na ile 15 atakuwa ni 3 centimeter. So distance hiyo hapo due north 4 centimeter. And tayari hapo nimeshapata jibu. Sababu 4 na 3 by Pythagoras unapata 5. So it is 4 centimeter. Yule pale, that is 4 centimeter. due north, and then 3 centimeter due east, 3 centimeter due east, tutafika mpaka pale, that will be 3 centimeter, and then finally the resultant vector, the resultant vector is given by this line connecting the two, which is 5 centimeter. Inaonekana kabisa hapo. So 4 3 itapata 5 centimeter. Converting back to this scale, tutapata ni 25 meter. Lakini hata ungetumia Pythagoras theorem kule mwanzoni, bado ungekuja kupata hiyo 15 square. Japo hesabu yako ingekuwa kubwa wa kutumia kichwa, lakini bado the final answer will remain the same. A brick is pulled by a force of 4 Newton acting northward and another force of 3 Newton acting northeast. Find the resultant force of these two forces. So nitatumia force, nitatumia scale ya 1 to 1, kwamba 1 centimeter represent 1 Newton. Kwa hiyo brick is pulled by 4 Newton acting northward. 4 Newton is ina act kwenda north, so nitakuwa na 4 centimeter acting to the north. Tuko na 4 centimeter kama hivi ambazo zina act kwenda north, lakini pia tumeambiwa mwingine ana pull kwa 3 Newton acting northeast. So tunafahamu northeast, kama tukiweka hivi northeast inakuwa hapa, because here is angle of 90, northeast lazima iwe 45. So northeast, I will use my protractor to measure the angle ya hapo northeast. So I'm just looking for my protractor here to measure the angle ya northeast ambayo nataka iwe angle ya 45. So from here angle ya 45, mpime angle ya 45 ni hapa horizontal northeast. So angle 45 nitapima vector ambayo itakuwa na centimeter 3 centimeter. So my vector hapa itakuwa ni 3 centimeter. And then what is the resultant vector? Tutamdraw pale from here, tutamdraw straight line up to there, ambayo tutapata kutoka hapo. So tukimpima hiyo line vizuri, tutaona atakuwa ni 6.6 centimeter. 6.6 centimeter. And tukirefer back kwenye scale yetu tuliyoweka, so this will be equal to 6.6 Newton. 6.6 Newton. 6.6 ukirudisha hapa itakuwa 6.6 Newton. Our question number 7. Two forces AB and AD of magnitude 40 and 60 reactive are pulling a body on a horizontal table. If two forces makes an angle of 30 between them, find the resultant force on a body using parallelogram law. Kwa hiyo swali kama hili tumeshafanya hapo juu, tuliweka tu angle ilikuwa 60, hapa angle ni 30. Swali ni ile hapa tu angle ni 30, ila finally jibu ni lile au swali technique ya swali liko nataka technique gani? Technique ni ile. Kwa hiyo halina haja sana ya kuona kama ni swali ambalo linaweza likawa ni gumu. Now let's move to the last numerical problem. In our last numerical problem tumepewa string kama hizi hapa. Tuna string hiyo hapa na string hiyo hapa. So we have two rope 3 cm and 6 cm long are tied on a sailing and their force ends by pulling 100 Newton and the angle of 30 between them. Sasa swali ni kwamba find the tension in each rope if they make angle of 30 between them. Kiufupi ni kwamba huyu force anayevuta kwenda hivi ni sawa sawa na force atakayekuwa ni total wa hao kwenda hivi. So kumbuka hawa ni string, so we don't know the tension in the string. The easiest way to solve this question is by letting the string length to be vectors and to solve the resultant vector by parallelogram law. Kwa tunatafuta total resultant vector hii string hapa, then hii tuna equate na length hii. Toka hapo tunatumia comparison. So from there we have 3 meter, and let us use the scale of 1 centimeter represent 1 meter. So we have 3 meter ambaye tunataka tuchore parallelogram. So tunaweza kuchora 6 meter in horizontal, ambaye 6 meter atakuwa kama 6 centimeter. So tutamchora pale 6 meter kwenye horizontal. From here tutamchora mpaka hapa 6 meter. And then after drawing this 6 meter, we'll measure the angle of 30. Tutapima hapo angle. So we measure the angle of 30. So angle of 30. Tutapima angle ya 30. Angle ya 30 itakuwa ni hapa. After measuring this angle, na ni vyema tu na hapa tungepima kabisa. Tungepima kabisa angle ya 30 hapa. So angle ya 30 na angle ya 30 hapa tunaweka 3 centimeter. Centimeter tunaweka ni mpaka hapa.